Hello everyone, welcome back to our channel. Today, we're going to build an IoT camera system using an OV2640 camera and the W6300-EVB-Pico2. This project is special because we can select MQTT or HTTPS to send pictures to the internet. Why include both? To demonstrate the board's capability to handle different communication protocols, making your projects more flexible and reliable. We'll capture images with the camera module and send them to Adafruit IO using Ethernet. This wired connection makes our camera system super stable and reliable, perfect for applications where you can't afford to lose connection. Okay, let's get started building. First, let's talk about what components we need for this project. The main parts are the OV2640 camera module and our W6300-EVB-Pico2. This camera module uses I2C communication to control its settings, and it can output JPEG images directly, which is perfect for sending over the internet. You can choose from many different resolutions with this camera, from very small all the way up to quite large. For our project today, we'll be using the 640 by 480 pixel setting, which gives us good clear images without making the files too big to send over the network. Now, why the W6300-EVB-Pico2? It's perfect for cameras. It has a fast processor to handle images, lots of memory, and a special QSPI interface with 64 kilobytes of internal buffers for sending and receiving data. The built-in Ethernet gives us a super stable connection, exactly what a reliable camera needs. Before we start building, there's some preparation we need to do. If you haven't set up your board yet, please watch our previous setup video first. Once your board is ready, you need to make sure you've downloaded the right libraries to your board's lib folder. The four most important libraries for this project are Adafruit requests for HTTPS communication, Adafruit MQTT for MQTT messaging, Adafruit IO for connecting to the Adafruit cloud service where our images will go, and of course Adafruit OV2640 for controlling our camera. Now, let me show you how to connect everything together. I have a circuit diagram here on screen that you can reference. Here's a very important part that many people miss. You absolutely must use pull-up resistors on the I2C lines. Without them, the communication lines will float and cause errors. The camera won't be detected by the board and nothing will work. You need two resistors, each connecting between the 3.3 volt power and the I2C lines. Standard 4.7 kiloohm resistors work perfectly, though anything between 2 kiloohms and 10 kiloohms should work fine. Now let's look at the circuit connection. The camera connects to several pins on our board. We have VSync going to GP12, HREF to GP11, and PCLK to GP10. The 8 data pins D0 through D7 connect to GP0 through GP7. The I2C clock line SCL goes to GP9, and the I2C data line SDA goes to GP8. There's also an optional reset connection to GP13 if you want to use it. And always remember to double-check all your connections before you power anything on. A quick visual check can prevent short circuits and save your components from damage. For the software setup, if you need a refresher on MQTT and Adafruit IO configuration, check out our previous video linked in the description. In Adafruit IO, I've created one feed for storing the image and set up a dashboard to visualize it. Important tip: remember to turn off the feed history storage in Adafruit IO settings. If you don't do this, you'll be limited to uploading only 1 kilobyte files, but with history turned off, you can upload images up to 100 kilobytes, which is perfect for our camera project. Now let's look at the code. The Ethernet setup is similar to our previous projects, but let me walk you through the camera-specific parts. First, we need to set up the camera. We initialize I2C communication using pins GP8 and GP9. This is how we talk to the camera to control its settings. Then we configure the OV2640 camera module with all the necessary pins. The camera uses an 8-bit parallel interface for fast data transfer. That's why we need pins GP0 through GP7. We also have control signals. The pixel clock on GP10 for timing, VSYNC on GP12 to know when a new frame starts, HREF on GP11 for row data, and an optional reset pin on GP13. We set the resolution to 640 by 480 pixels and tell the camera to output JPEG format directly, which saves us from having to compress the images ourselves. Now comes an interesting choice in our code. We give you the option to choose between HTTPS or MQTT protocol. When the code starts, it asks you HTTP or MQTT. Based on your answer, it sets up the appropriate connection. If you choose HTTP, it creates an HTTP client with SSL security. If you choose MQTT, it connects to Adafruit's MQTT broker. This flexibility lets you pick the protocol that works best for your situation. The main part of the code is a continuous loop that captures and sends images. It starts with a 15 kilobyte buffer for memory efficiency. The camera captures a JPEG image into this buffer, and if we get a valid image, we convert it to base 64 format so it can be sent as text. Here's an important detail about the data handling. When we send the base 64 image, MQTT can use the bytes directly, but HTTPS needs the data converted to a string first. That's why in the code, you see .decode UTF-8 only for the HTTPS. It's converting bytes to string, so HTTPS can send it properly. MQTT handles the bytes just fine without conversion. The code is smart about memory management too. If the image is getting close to filling our buffer, it automatically increases the buffer size for the next capture. If we run into memory problems, it reduces the buffer size. This adaptive approach helps keep things running smoothly, even with limited memory. After each image is sent, the code does garbage collection to free up memory, then wait 3 seconds for capturing the next image. This timing gives the network time to send the image and prevents overloading either our board or the Adafruit IO service. Let's see it in action. First, I'll demonstrate the MQTT mode. Watch as the board connects to Adafruit.io, and there it is connected. Now the program starts capturing images. You can see in the serial monitor, it shows the image size and keeps uploading to the feed. Each image appears on our dashboard almost instantly. MQTT is really fast because it keeps a connection open. Now let me switch to HTTPS. Notice the difference? The images still come through, but there's a bit more delay. That's because HTTP needs to set up a secure SSL connection each time, and there's more back and forth communication with the server. So HTTPS is a bit slower than MQTT, but it's more compatible with some networks. And that's our IoT camera project. We've successfully created a reliable Ethernet-powered camera that can stream images using either HTTPS or MQTT, giving you flexibility for different network environments. If you enjoyed this project, please give it a thumbs up and subscribe for more IoT tutorials. All the code and circuit diagrams are available in the description below. Thank you for watching, and we'll see you in the next video. Bye-bye.